So here we have the very last question in the Chapter 5 homework. There are a lot of questions built into this problem, and none of them are really that hard. You just have to take things step by step and keep some careful notes along the way. That's helpful if you do that. And then just really follow the instructions. So my numbers will be different, but the approach to solving each part of the problem will be the same. First thing you're asked in 1A is to calculate the CM ratio at this level of sales, and then to also calculate the number of balls that need to be sold to break even. So the CM ratio I can calculate a couple of different ways. I can take the sales price of $36, subtract the variable expenses per ball to get the unit contribution margin, which is $10.80, and then take the $10.80 in unit CM and divide by the $36 sales price. My answer is 30%, my CM ratio. I could also do it with these dollar amounts. The total dollar amount of contribution margin divided by the total dollar sales revenue will get the same 30% figure. So then, to figure out how many balls does the company need to sell to break even, I'm going to use that shortcut formula where I put fixed costs, $540,000, and that's given to me here, divided by the unit CM. My answer of 50,000 represents the number of units or balls that I need to sell in order to break even. And since I was looking for the number of units, that's why I divided by the unit CM. If instead I was looking for the sales dollars necessary to break even, I would take the same amount of fixed expenses and divide by the CM ratio instead. Down here in part 1B, I'm asked for the degree of operating leverage at last year's sales level. These numbers represent last year's sales level. So to calculate degree of operating leverage, I'll always use this formula: contribution margin, 594,000, divided by net operating income, 54,000. And my answer represents the degree of operating leverage at this level of sales. Now moving on to question 2, it says, due to an increase in labor rates, the company estimates that variable expenses will increase by $2.16 per ball next year. So you'll see that I took the old variable expense per unit and added the 216 to get my new variable expense per unit. Then it says, if this change takes place and the selling price per ball remains constant at $36, what will be the new CM ratio and break-even point in balls? So here I'm taking the same $36 sales price, subtracting my new variable expenses per unit to get my new unit CM. Then I divide by the sales price to get my new CM ratio, 24%. And then to calculate the new break-even point in balls, which of course would be in units, I'm going to take my fixed expenses, those haven't changed, and divide by my unit CM. And my answer, it got cut off a bit here, but it's 62,500 balls that I need to sell now in order to break even. Down here in question 3, I'm asked to refer back to the data in number 2. So in other words, I'm going to use these new variable expenses per unit to answer this question. How many balls will have to be sold next year to earn the same net operating income, 54,000, as last year? So Now we're going to use our target profit shortcut formula, where we take target profit, that's 54,000, plus the fixed expenses, and divide by the unit CM. And because I'm referring back to the data in part 2, I'm going to use this new unit CM to figure this out. So here I've done that. My answer when I divide is 68,750 balls that I need to sell now in order to earn the same amount of net operating income, 54,000. All right, in part 4 of the question, it asks, if the variable costs increase, what selling price needs to be charged to keep the contribution margin ratio the same at 30%? And so this is the same CM ratio as we had in the very first part of the problem. Now my numbers have changed a little bit because I prepared this PowerPoint with different numbers. Again, the process for solving the question will be the same regardless of your numbers. So here we're going to do a bit of algebra. And so let's say that this is our original data provided in part 1 of the problem. The skateboard's selling for 36. Variable costs now are $25.20 per skateboard. And CM ratio with these figures is 30%. So here's how we would figure out what sales price we need to charge in order to maintain the same CM ratio even with the increase in variable expenses. So you'll need to take your new variable expense figure after the increase, and let's set the sales price. This is what we're trying to determine, what the sales price needs to be. Let's say that's our X. And remember, the way we calculate CM ratio is we take the sales price, subtract the variable expenses, that represents our unit CM, and unit CM divided by sales price. In our problem, with the original data, that's set to 30%. So this is just the formula for calculating the CM ratio. Unit CM, which is what we'll get up here, divided by sales price equals CM ratio. And we want that to be equal to 30%, the same CM ratio that we had in part 1 of the problem. So we need to solve for X to figure out what does that sales price need to be. So we're going to solve this algebraically, first by multiplying both sides by X. And when we do that, that eliminates the X in the denominator on the left side, adds an X here, or we're multiplying by an X on the right side. Then if we add 2736 to both sides and subtract 0.3x from both sides, we end up with this equation. And then 1x minus 0.3x equals 0.7x. So we're setting that equal to 2736. And then finally, when we divide both sides by 0.7, we get our answer. And this would be the selling price that the company needs to sell each unit for in order to maintain the same CM ratio even with the new variable expenses per unit. Now let's look at question 5. It's asking us to refer back to the original data. So we're going to go right back up to that table at the very at the very top of the problem. And now the company is discussing the construction of a new automated manufacturing plant. The new plant would slash variable expenses per ball by 30%, but it would cause fixed expenses per year to increase by 80%. So what I've done over here on the left is I'm going back to my original variable expense per unit, of 2520, this amount is going to be decreased by 30%. So what I did here as a shortcut is, since this amount is decreasing by 30%, I'm finding out what's 70% of this number, because 70% will represent my new variable expense per unit. I also could have taken this 2520 multiplied by 30% and then subtracted that from the 2520 to get the 1764. Now my fixed expenses of 540,000, those are increasing by 80%. And here's a shortcut for figuring out the new amount of fixed expenses. Multiplying by 1.8. I also could have multiplied this figure by 0.8 and added it on to the 540,000, and I would have gotten this same number. So now they're saying, if we go ahead and do this and build a new plant, what would be the company's new CM ratio and new break-even point in balls? So down here on the left, I've calculated the new CM ratio. We're going back to the original sales price of $36 because we're using that original data. We're subtracting the new lower variable expense per unit that I just calculated, getting our new unit CM, dividing by the sales price to get the new CM ratio. Last, it asks for the new break-even point in balls, and here we need to be careful to follow instructions. It says, do not round intermediate calculations, but round up your final break-even answers to the nearest whole number. So to get that new break-even point, I'm going to take my new fixed expenses that I calculated here, divide by my new unit CM, which I calculated over here, and my answer, you can see, has some digits to the right of the decimal, but I was told to round up to the nearest whole number. So you would think that we should just round to 52,941, but it tells us to round up. So I'm just going to round to 52,942, and that would be my answer. Okay, last part, 6A. Now it's saying to refer to the data in 5, and 5 is where we assumed the variable expenses per ball would be cut by 30% and the fixed expenses would increase by 80%. So we're going with those figures, and it says, if the new plant is built, how many balls will have to be sold next year to earn the same net operating income of $54,000? So we're going to do target profit analysis. We're going to take the new fixed expenses, add the $54,000 in profit that we're trying to achieve, divide by our new unit CM, which we calculated back in part 5. Here's our answer. Here, they don't tell us to round up. So we're going to then go ahead and just drop these digits to the right of the decimal point. We're not rounding up because they didn't tell us to do that. So we're just going to go ahead and go with this number after dropping the digits to the right of the decimal. Now, if you've already done this problem and turned it in and got it wrong just because of rounding, please let me know. I'll give you the points back if it was just because of rounding. But if you haven't submitted it, be sure not to round up for this part 6A. Finally, in part 6B1, it asks us to prepare a contribution format income statement based on the company selling 55,000 balls, and based upon the new plant being built, which means our fixed expenses are going up to this amount, our variable expense per unit will be the amount we calculated in Part 5. So I've gone ahead and prepared that using the $36 sales price, the original price from Part 1 of the problem, but multiplying the 55,000 units by the new variable expense per unit, using the new fixed expenses, and just for the heck of it, I went ahead and calculated our new degree of operating leverage. The last part got cut off, but when I take the new contribution margin divided by the new net operating income, I get 26.71, our new degree of operating leverage.